Hi, I'm Scott McLean from transmusicmastery.com, and in this video I'm going to give a brief overview of the Sylenth1 synthesizer. So this is where all of the information that we've learned about synthesizers using Zebra 2 throughout this course really benefits us in learning to use other synthesizers, such as Sylenth1, because we can relate almost pretty much all of the concepts that we've looked at so far to any synthesizer we encounter. Now, not every synthesizer is going to contain the same features and certainly not sound the same, but as you'll see, it can be fairly straightforward to quickly learn a new synthesizer now that you've come to understand the different principles that are involved in synthesis from the previous modules in this course. So first, let's just look at Sylenth1. Now, if we look at this top bar here, this has a couple things on it. Polyphony, that's the number of notes that can be played at any given time. Okay, so if I wanted to play one note at a time, I could set polyphony to 1. So now if I play on the keyboard, in fact, I'm not hearing any sound right now because oscillator A1 has 0 voices. And if I make that 1 voice, now I can hear a sound. So let me go ahead and just set it to the init patch, init preset. So the init preset, we've got a saw wave shown here in the display, and voices is 1, and it sounds like. And you can hear and see the spectrum analyzer and the oscilloscope over here. Okay, so by now you should be familiar with what's being displayed there. Now, when we approach a synthesizer, the key questions we want to answer deal with oscillators, filters, and modulators. Okay, that's the 3 principal areas that we want to look at. Oscillators, how do we generate the sounds? Filters, how do we sculpt the sound? And then modulator, how do we modify dynamically the sound over time to give it movement and give it some interest. In Sylenth1 has 2 parts, part A and part B. Each part has 2 oscillators. So there's a total of 4 oscillators. You'll also notice that part A has an amplifier envelope right here, and part B has an amplifier envelope as well. So each part has its own dedicated amplifier envelope and 2 oscillators, oscillator A1, oscillator A2, oscillator B1, and oscillator B2. Okay, so I'm just going to select part A here. Each part also has its own dedicated filter. So there's filter A for part A, and if I select part B, we have filter B. Alright, then each part, the output of each part flows into the mixer. So we have a mix A, which controls the overall level of part A, and mix B fader here, which corresponds to the overall level of part B. And then the main level is the overall output of the synthesizer after mixing A and B together. Alright, and then the only other thing to note is this filter control. This actually controls both filter A and filter B, okay? And I'll talk about the modulations in a minute. This lower area is where the modulators are, the mod envelopes, Lfos, and then this 4-slot modulation matrix. Alright, so what we want to understand is how do we work with the oscillators? So working with oscillators means selecting waves. The way you do that in Sylenth1 is through this display here where it says wave. You click and move the mouse up and down, and that lets you move through different waveforms. So here we have a sine wave, a saw wave, a triangle wave, a square wave, a pulse wave, a narrower pulse wave, and then sort of it looks like a saw pulse combined, and then noise. Alright, so that's how you select waves in the oscillators on Sylenth1. I'll just set it to a saw wave for now. Another key question is how do I invert a wave? That's using this INV button here. So if I hold down a note and I select invert, you can see that the wave has been inverted. So let me do that again, and I'll actually click this button while I'm playing the note. So by default, when invert is not selected, the saw wave has a ramp up, and when you invert it, then the ramp is going down. Okay, so that's one feature of Sylenth1, is easy to invert the wave form. The other thing is, okay, how do we restart and set the phase position? Okay, on Sylenth1, that can be achieved using this retrig button. In fact, it's kind of difficult to hear with only one oscillator, so let me bring in a second oscillator. Now, phase will only take effect when you've set this retrig to true. So if I set this retrig to 2 on oscillator A2, I can now adjust its starting phase point relative to oscillator A1. And if I do a similar demonstration as I did for Zebra 2, if I pan oscillator A1 to the left and oscillator A2 to the right, now we can see the different waveforms and the different phase points. Let me do a saw wave and bring the phase to 0 and set retrig on both, so they both are guaranteed to start at phase 0. So now we see one solid waveform, just green. We don't see green and blue because they're both in phase with one another. But if I move the phase of oscillator A2, we start to see that phase separation occur. Alright, so that's how you deal with phase restart on note start, setting the waveform type, and inverting the waveform. Alright, another thing you want to control with oscillators are the tune or the pitch. And in Sylenth1 you can achieve that here with these two boxes. We have one for octave, so if I want to go up one octave, in fact, let me disable. Or down one octave. Or I can go down 2 or 3. Alright, so that's how you deal with tuning an oscillator. Notes, this would give me semitones, so it could be 1 octave plus 1 semitone or 2 semitones. Alright, and then you can fine tune the pitch with this fine knob. Okay, and then finally with voices, that's correlates to, okay, how do you stack waves? How do we stack waves in an oscillator? So with Sylenth1 you can have up to 8 waves stacked on top of one another. And then typically when we stack waves, we detune them, and that's accomplished with the detune knob. And volume of the oscillator is controlled by the volume knob. Stereo controls the stereo width. And in fact, I need to reset the panning in order to demonstrate that. Okay, so that takes care of going through the oscillator controls in Sylenth1. And the only other thing to point out is these little C and P buttons. Those are copy and paste. So if I wanted to, let's say, copy the settings from oscillator A1, I could say copy by clicking the C. And then if I wanted to paste it over here on oscillator A2, I could click P and it just copied all of these settings over to here. So that's just a convenience function within this synthesizer. Now, the amplitude envelope, that's your typical ADSR envelope, and that should be fairly self-explanatory at this point. But this would control your attack, your decay, the sustain, and release. And you can also copy and paste those settings if you wanted to copy amplitude envelope A to amplitude envelope B. Solo, that would allow us to solo one part. So I could solo only part A, or I could solo part B. So for example, I've got sound coming from part A. If I switch to part B, there's no sound because voices is at 0, but if I brought in voices of 3 on oscillator B1, now I'm just hearing part B. So this allows us to solo each part individually. And then sync, that is tempo sync to the host. Now, the next thing to talk about are the filters. So the question around filters would be, what's the routing? Okay, that would be one question we need to understand if we're going to use a synthesizer. We want to know, how is the signal routed from the oscillators into the filter? Well, in Sylenth1, the output of oscillator A1 and A2 will be routed into the filter. And there is some flexibility in this synthesizer, in that I could have oscillator A go into filter A. I can also have a combination of A and B. So if I wanted to, I could get oscillator B output and input that into the filter A as well. Or I could have no input into the filter, which would not allow me to hear anything. In fact, let me turn off B. So I'm hitting a note now and I'm not hearing anything because I've blocked oscillator A. I've disconnected oscillator A from filter A. So if I want to hear that, I have to allow it to go through the filter. Now it's going through the filter. The filter type here, a horizontal line indicates that it's no type. It's basically bypassing the filter module. The types available are a low pass, band pass, and high pass. And then they come in 12 dB slope or 24 dB per octave slope. It also has a drive control, which adds saturation to the filter, and a warm drive setting, which emulates sort of an old analog style sound. Okay, next, let's talk about the modulation settings. If we look at the modulation section down here, we can see there are 2 modulation envelopes, and each modulation envelope can control up to 2 modulation targets here. So if I wanted to, I could modulate cutoff A and B, or just cutoff A. If I only wanted to modulate cutoff A, I could do so this way, or cutoff B, or both. And this controls the amount of modulation. It could be negative or positive. And then the standard attack, decay, sustain, release settings. And I'll demonstrate how this actually works when we get to programming the patches. And then the next thing to look at is the LFOs. We've got sine, looks like a saw, sine, saw, a ramp, square, pulse, half pulse, quarter pulse, and then a triangle saw wave combined. And then this would be more of a sort of random glide type effect, and then a random pulse type effect this is called sample hold, and then random, completely random. And then finally the modulation matrix. So instead of, like on Zebra 2, we had 12 slots in the modulation matrix, Sylenth1 has 4 slots. Each slot can target up to 2 modulation targets. Now, when you're looking at modulations, that's one thing you want to understand is, well, what can I modulate with this synthesizer? All right, what does it allow me to modulate? It doesn't allow me to modulate everything, okay? The question is, what does it allow me to modulate? Well, we can modulate volume A, volume B, volume AB, pitch, phase, panning, cutoff, resonance, the phaser frequency, mix A and B, LFO rate, gain, and distortion amount. And that's it. So fairly common to modulate volume and pitch and phase and panning and filter cutoff and filter resonance. So all the common modulation targets are supported. And then the question is, well, what could be a source of modulation? So if we select this, we could modulate based on velocity, the mod wheel, key track, the amplitude of envelope A, envelope B, modulation of envelope 1, envelope 2, and LFO 1, 2, aftertouch and step velocity. And I'll use step velocity. Actually, I think that was probably off the screen, so let me do this. LFO 2, aftertouch, step velocity. I will use step velocity when I do the high roller bass. And that's about it. There's some legato portamento settings here. This corresponds to what we saw in Zebra 2 with glide. There is, if we look at part B, it's the same thing. And then finally, that draws our attention to the center section, which are the effects. And we've got an arpeggiator step sequencer here. I will use this in the high roller bass, a distortion effect unit, phaser, chorus, EQ, delay, reverb, and a compressor. Now, one thing to keep in mind, these are, from the signal flow perspective, these are in a specific order. And it's pretty much top to bottom until you get to the delay and reverb. The reverb actually comes before the delay, and then the last thing is the compressor. So it goes, well, in fact, it's distortion first, then the phaser, then the chorus, then the EQ, then the reverb, then the delay, and then the compressor. So if you recall from watching some of the Zebra 2 patches, sometimes the delay was before the reverb, sometimes after it, and so forth. You don't have that flexibility with Sylenth1. And that may or may not cause problems depending on what type of patch you're looking to do. But just keep it in mind. Alright, so that's a basic overview of Sylenth1. Let's go ahead and actually program some patches that we programmed earlier in the course on Zebra 2 using Sylenth1 and see what kind of differences we run into. I'll see you in the next video.